Let's investigate the time invariance of a time scaling system. Okay, here's the formal definition. The output signal y of t is the input signal x of t, but the time t is scaled by a constant alpha. Okay, let's investigate what this system does to a signal by looking at a boxcar signal. So the input signal x of t is a boxcar, and the output y of t, it depends on the value of alpha. So if alpha is larger than 1, the boxcar signal will be compressed, will be scaled in time to be shorter. Let me demonstrate this with audio.
The boxcar signal will be compressed, will be scaled in time to be shorter.
Okay, if alpha is between 0 and 1, the input signal will be stretched in time. Here's an example of this type of a scaling with audio. Okay, let's see if this system is a linear system. Here's the formal test for linearity. So we have a linear combination of outputs. So we feed in a signal x1 and x2 into the system t separately and scale them with arbitrary coefficients c1 and c2. Now on the right hand side, what we've done is we've fed a linear combination of x1 and x2 into a single system, and we've done the linear combination before we feed the signal into the system. Here's the test of linearity in diagram form. Essentially this means that the top diagram and the bottom diagram need to be equivalent. For any values of x1, x2, c1 and c2, the output y1 needs to be equal to y2 for the system to be linear. In order for the system to be linear, the left hand side needs to be equivalent to the right hand side. And if we evaluate the left hand side, we get this. And in the case of the right hand side, we get the same. This means that the time scaling system is a linear system. Okay, let's apply a time scaling to this video with alpha is larger than 1. Okay, now is this time scaling system time invariant? We're going to have to do the formal test for time invariance. So the formal test of time invariance is that we should be able to apply a time shift to the input signal before or after feeding the input into the system and get the same results. Here's the same test in the form of a diagram. Basically, the left-hand side should be equivalent to the right-hand side. y1 should be equivalent to y2 for any value of x. Okay, so let's apply this system. Let's first do the time delay on the left-hand side. So that means that the input signal x will be shifted by time tau. Here's a brief reminder of what the system D means. It's a time shift. It just applies an addition of tau to the time variable. Okay, so now on the right hand side we'll first evaluate the system on x. That will be time scaled version of x. So x of alpha times t. And finally, if we now apply system t to the delayed signal on the left, we get x of alpha times t plus alpha times tau. On the right hand side we get x of alpha t plus tau when we apply the time shift, and these are not equal except for the trivial case where alpha equals 1. So the left hand side is not equal to the right hand side, which means that this is not a time invariant system.